Hi, today we have a nice trigonometric problem and we're gonna solve it 3 ways. Okay, we have sin x plus 2 cos x equals 1 and in the range of negative pi to pi. Using the Weierstrass substitution, we have t equals tangent x over 2. Then if we have t equals tangent x over 2, we have sin x equals 2t over 1 plus t square and cosine x equals 1 minus t square over 1 plus t square. The values of sin x and cosine x came from the double angle identity. These substitutions, the t sin x and cosine x, is the general way of doing the Weierstrass substitution. Substituting our values for sin x and cosine x, we have the sin x become 2t over 1 plus t square plus 2 times cosine x, same as 1 minus t square over 1 plus t square, and we transfer 1 on the left hand side, become minus 1, all equal to 0. Now multiplying both sides by 1 plus t square, we have 2t plus 2 times 1 minus t square minus 1 plus t square, all equals 0. Now apply distributive property, we have 2t plus 2 minus 2t square minus 1 minus t square equals 0. Combine like terms, we have negative 3t square plus 2t plus 1 equals 0. And multiply by negative 1, we have 3t square minus 2t minus 1 equals 0. And the factor for this, we have 3t plus 1 times t minus 1 equals 0. Hence, the solutions are t equals negative 1 over 3 and t equals 1. Using t equals 1, using the substitution t equals tangent x over 2, we have 1 equals tangent x over 2. And we take the inverse tangent, and we know that the inverse tangent of 1 is pi over 4 equals x over 2. And rearranging, we have x equals pi over 2. We have a solution at pi over 2. We can try to substitute pi over 2 to our original problem. We have sin pi over 2 is 1 and 2 cosine pi over 2 is 0. So it's true, 1 equals 1. Hence, pi over 2 is one of our solution. Now using the t equals negative 1 over 3, we have negative 1 over 3 equals tangent x over 2. And we take the inverse tangent of both sides. We have the inverse tangent of tangent x over 2 is x over 2. And we keep x over 2 on the left hand side equals the inverse tangent of negative 1 over 3. And it's a property that the inverse tangent of a negative same as negative inverse tangent of 1 over 3. Multiplying both sides by 2, we have x equals negative 2 inverse tangent of 1 over 3. So we have another solution at negative 2 inverse tangent of 1 over 3. We're done with the Weierstrass substitution. Now we proceed using the unit circle identity. We know that sin squared x plus cosine squared x equals 1. Then we can say sin x equals to square root of 1 minus cosine squared x. Substituting square root of 1 minus cosine squared x, we have the sin x become square root of 1 minus cosine squared x plus 2 cosine x equals 1. Transferring 2 cosine x to the right hand side, and we square both sides. The left hand side become 1 minus cosine squared x, and the right hand side become 1 minus 4 cos x plus 4 cosine squared x. We can cancel 1, and rearranging our equation become 5 cos squared x minus 4 cos x equals 0. Factoring cos x, we have cos x times 5 cos x minus 4 equals 0. Now the solutions are cosine x equals 0 and cosine x equals 4 over 5. Since we square our equation, it gives an additional root, so we need to check our solution. When cosine x equals 0, we can have x equals pi over 2 and negative pi over 2. Pi over 2 is a solution, but negative pi over 2 does not satisfy our equation. Hence, we can only have x equals pi over 2. Now, for cos x equals 4 over 5, we have x equals plus minus the inverse cos of 4 over 5. Because on the first and fourth quadrant, we have positive cosine x values. Positive arc cos 4 over 5 refers to the angle above the x-axis, while the negative arc cos 4 over 5 refers to the angle below the x-axis. Arc cos 4 over 5 refers to the triangle that have adjacent part of 4 and hypotenuse of 5, and the opposite is 3 by Pythagorean theorem. These values of x, only negative arc cos 4 over 5 will satisfy our equation. Hence, our solutions are pi over 2 and negative arc cos 4 over 5. You might be wondering, using the Weierstrass substitution, give x equals negative 2 arctan 1 over 3. These two angles are actually the same, just of different form. We can prove it quickly. The two negative cancel. We have 2 arctan 1 over 3 equals arc cos 4 over 5, and arc cos 4 over 5 same as arctan 3 over 4 using the unit circle. Taking tangent both sides, we have tangent of 2 arctan 1 over 3 equals tangent of inverse tangent of 3 over 4 same as 3 over 4. For left hand side, apply double angle identity for tangent. We have 2 times the tangent of the angle same as 1 over 3 over 1 minus the square of the tangent of the angle. We have 1 minus 1 over 3 square same as 1 over 9. Simplifying, we have 2 over 3 over 8 over 9. Take the reciprocal of the denominator. We have 2 over 3 times 9 over 8. The 9 and 3 become 3, and 2 and 8 become 4. So we have 3 over 4 and equal to 3 over 4. Hence, these two angles are actually the same, just of different form. Okay guys, the last, using the complex analysis. For me, using the complex analysis and the Weierstrass substitution is the general way of solving the trigonometric problems. In complex analysis, we denote sin x equals z minus 1 over z over 2i, and cos x equals z plus 1 over z over 2, where z equals e to ix and I equals the imaginary number square root of negative 1. These values of sin x and cosine x came from the Euler's identity. Now substitute these values. We have z minus 1 over z over 2i plus 2 times z plus 1 over z over 2 equals 1. For this term, multiply both numerator and denominator by I times I is same as negative 1. So the denominator become negative 2, and we distribute that negative on the numerator part, become negative z plus 1 over z times I over 2, and plus 2 times z plus 1 over z over 2 equals 1. Multiply both sides by 2, we have 2 minus I times z plus 2 plus I times 1 over z equals 2. Combining the terms that have z and 1 over z. For z, we have 2, we distribute 2, and I, so we have 2 minus I times z plus 2 plus I times 1 over z equals 2. Now, we multiply both sides by z. We have 2 minus I times z squared plus 2 plus I. The 1 over z become 1, and the right hand side become 2 over z. Transfer 2 over z on the left hand side. We have 2 minus I times z squared minus 2z plus 2 plus I. Now use the quadratic formula. We have z equals the negative b become 2 plus minus square root of b squared is 4 minus 4 times ac, which is 2 minus I and 2 plus I, all over 2a, same as 2 times 2 minus I. You notice inside the radical we have 2 minus I times 2 plus I, which is a product of 2 conjugates. So we just square the first term, 2 square, minus the square of the second term, I square. And I square same as negative 1. Negative 1 times negative is plus 1, so we have 4 plus 1, so become 5. Inside the radical we have square root of 4 minus 4 times 5. 4 times 5 is 20. So inside radical we have 4 minus 20 is negative 16, and square root of negative 16 is 4i. So numerator part become 2 plus minus 4i all over 2 times 2 minus I. Cancel the 2, we have 1 plus minus 2i over 2 minus I. To remove the I in the denominator, we multiply by the conjugate. So we multiply both numerator and denominator by 2 plus I. The denominator part, we have 2 square minus I square. And again, I square is negative 1 times negative, we have plus 1. So the denominator part is 5 and the numerator part is still the same. So we have two solutions given by the plus minus 2i. When 2i is positive, we have distributing or apply the FOIL method, we have 2 plus I plus 4i minus 2 all over 5. Simplifying, we have the 2 and negative 2 cancel, we have 5i over 5 equals I. Now if 2i is negative, we have 2 plus I minus 4i plus 2 all over 5. Simplifying, we have 4 minus 3i over 5. Same as 4 over 5 minus 3i over 5. The real part is 4 over 5 and the imaginary part is negative 3 over 5. In complex analysis, what does z equals I and z equals 4 over 5 minus 3i over 5 mean? I in complex plane denotes the point at 0 and positive I. The angle made by the positive x-axis towards the I is pi over 2. Hence, we have a solution of pi over 2 using the complex analysis. For z equals 4 over 5 minus 3i over 5 denotes the points in complex plane having coordinates of 4 over 5 and negative 3i over 5. To find the other solution, we just need to find the angle made from the x-axis toward this point. If this triangle have real part same as the adjacent of 4 over 5 and opposite of negative 3 over 5, then the angle made same as negative arctan 3 over 5 over 4 over 5, same as negative arctan 3 over 4. Summary, our solutions are x equals pi over 2, x equals negative 2 arctan 1 over 3 using the Weierstrass substitution, x equals negative arc cos 4 over 5 using the unit circle identity, and x equals negative arc tan 4 over 3 using the complex analysis. And these three angles are the same, just of different forms. Okay guys, that's all. What method do you like the most?